Mr. V. Matish to light the lamp. I request our respected Dr. S. Mohammed Abbas sir, Head Center for Innovation and Incubation, PERI Institute of Technology to light the lamp. To represent our participants, I invite Dr. Shanti, Associate Professor, New Prince Sri Bhavani College of Engineering and Technology to light the lamp. I invite Mr. T.S. Vigneshwaran, Assistant Professor, New Prince Sri Bhavani College of Engineering and Technology to light the lamp. Thank you, dignitaries. Thank you, participants.
So that's what our topic. When you take a robot manufactured before 10 years, it will only obey the orders. It will not understand human being. It will not take the intelligence. Whatever I said initially, it was a human efficiency in the 18th or 19th century. All the works combined together is a human efficiency. And in 20th century, all the works are mechanical efficiency. Now it is 21st century. What is that? Cognitive efficiency. Cognitive efficiency means we have a lot of data, how the human being think, how the human being analyze and understand the working progress. Now, this intelligence has been implemented in Industry 4.0, means the robots are given intelligence, right? So it is called cobots. Cobot means collaborative research and collaborative working environment with the human intelligence presence with the robotic replacements. Right. So now, when you manufacture these things in Industry 5.0, what will happen? The robots will start think, analyze, and work accordingly. Right. That's what coming with all robotics, artificial intelligence, and IoT. The other part of Industry 5.0 is sustainability, where we struggle a lot. When you take the last 10 to 15 years, you cannot even predict what kind of cyclone comes and what kind of disaster comes. Right? When you take fire, it is existing. When you take temperature, it is much more. When you take flood, it is also more. So all this comes under improper sustainability. And are we working towards
that type of fruits, those things you didn't see before? So just to group it, how many new types of birds you have seen, new insects you have seen, new fruits you have seen. Like that we group it. Sometimes the birds may group, they may go group, that you can find out. So without desired output, you will be training, the data will be available. Then semi-supervised means you know few information about the data and the output, not complete data will be. For example, some fruits you know already, some fruits you don't know. That is semi-supervised learning. In reinforcement learning means for each action you will be giving some reward. If you have dogs, you can see this type of learning. To the dog, you tell the dog to jump or something, then you give some food to the dog and see that it obeys you, and once it is
penalty. Now there is a huge oversupply of computer science. Only first batch, once it comes out in a different terms like ADS and data science, so is that they will start suffering because now the intake will reduce there. There is no job, so the intake definitely reduce there. Who the first they will touch is in cost cutting measure in faculties and their salaries. So for that you have to do this cross disciplinary PG certification so that wherever the opportunities are there you can move. So then these are the some kind of internship program at IITs for the faculty who are doing the PhDs. Okay, so I will explain you that presentation in elaborately. And these are the measures are available you have to travel for your paper publications either in abroad or in India. And these are the modes are available where you can organize the event in your college. These are the funding modes. If you just type text in your Google and ask, it will tell you how to apply, where to apply. And some faculties may be interested in startup or incubation center to set up in their college. So for that, there are 2 schemes by the government, PRISM and PERI. And there are some good postdoctoral fellowship, doctoral fellowships, and abroad fellowships. These are the good fellowships only I have mentioned here, so you can think about it. So this is the entire ecosystem in our country for the funding for all the faculties, including the ladies, in all the ways. So we'll see in details in maybe 2 o'clock. So quickly I will just take it up some case studies and wind up. So materials are, as I said, the backbone for any applications. So just to make you understand, there is no material system. Forget about what is a material system. And I want to find out the relation between this material system, chemical composition and hardness. This is my ML problem statement. And I want to optimize this composition so that I'll get the best composition which will give me the best hardness, higher hardness. Okay. So 2 ways you can use the ML. So we have pulled out the data from the data source like journals. In and around this system, there are about 483 data points. Clean the data. Our objective is set very clearly. There are about 3 plus 7 elements are there. In that, only 2 elements variation, how it is impacting the properties I want to study through machine learning, like molybdenum and titanium, the last 2 elements. I know it is very difficult for you to understand what is it, because you studied only in school. Just for the idea's sake, this you take it as an example. But how we use the ML, you will see. Typically, you find these are the ML algorithms are used for regression problem. Okay, and the purpose is to find out the optimized composition, like how much percentage molybdenum, titanium I have to use, so that I get the best hardness, that is 850. Okay. So if you are writing the paper ML and trying to understand the using the regression and understand the model performance, you should understand the model performance parameters. So if you are writing the paper, these 2 must be there. Root mean square error, R square. There are other measures also, I will talk about it. So look at this R and SE values and R square value. Okay. So you have to compare for all these ML algorithms. Any algorithm you select, these model parameters you have to measure. There are about 5. Okay. R square should be close to 1. Then you have ideal fit. Anything deviating from 1, based on the number, you can tell how the model. So how to say which is the good? Where is the root mean square error is lowest value among all? So maybe RF or XG boost or decision tree, and coupled with R square, which has close to 1. So 0.97, this is XG boost. So we can say this XG boost is the best algorithm among all the ML algorithm, which can help me to predict the composition, gives the best hardness. So, and second thing is, out of these 7 elements, which elements have a high influence on the property? This also through ML you can study. What is the future importance? Okay. So future importance is the one you have to get the output. Second is, how is your model performance measures? So one simple example I told you. Then directly I will get into the that measures the interest of time.
Everyone? Now you can see this is an ultrasonic sensor which is used to find the distance. Based on this sensor, we can make an obstacle avoidance kind of robot, or can make a digital scale to find the distance. In the screen, you can see the distance, which it measures the actual distance. So now I am using this sensor, but there is no use case. So in this case, it is a closed loop where it only shows the distance. It doesn't involve any particular task. So to use it as an open loop, we need to use this in a particular application. For example, if you are doing any smart dustbin, it's a kind of project where you use this sensor and we attach to the dustbin. So it identifies when the person comes near to them, then it automatically opens the lids. After a particular set time or the person moves away, the lid will automatically close. So when the task is included and it is used its output as the feedback, then it is called an open loop until it is a closed loop. Okay, fine. Any doubts? This is an example for a sensor. You all familiar with this? Or do you want any explanation how it works? Anyone need explanation like how it works, this sensor? Or I can go with another sensor. Explain? Okay, fine. Now I will give you the explanation. In this sensor, it contains of two things. One will be transmitter and one will be the receiver. The transmitter will transmit the ultrasonic sounds, okay, which is not audible by the humans. So when the system is turned on, it will keep on sending the ultrasonic sounds. When it is touching any object and it reflects back and it will be received by the receiver, then the process will start. It will sense the time which it starts to send the ultrasonic sound and gets back. Like if it is takes 2 seconds, the object is at the 1 feet. So time is taken to touch the object is 1 second and get the reflection back is a 2 seconds. So the system will be fed like if it takes 2 seconds to get the signal back, the object is at the 1 feet distance. Like that we have to calibrate the system. Once it's set. Now if the system is taking 4 seconds to get the feedback, so the system will think the object is at the 2 feet distance. So based on this calibration only the sensor keep on works. So if it takes only around 6 seconds, 8 seconds, based on the time, this object, the sensor knows the object distance. Okay. Yeah, is the limitation. It works up to 2 meters. 2 meters is its maximum limitations. If you want to go further, we should go for LiDAR technology, which uses laser. That can go up to meters. Okay, sir? It will be reflected in the glassy surface, water surface, it will not be effective. But this is an ultrasonic sensor, no issues. It can work on base reflection surface, transparent, solid or water kind of anything it will work. But the distance will be the limitation.
Always the distance will be half of the.
What's that?
Always the distance given by the sensor will be half of the number of clicks.
Yes, sir, and we are going to use the formula to multiple twice. In this system also, in the program we can see there is we used a formula. This is used to multiple the time taken, so we can get the actual distance. Any other doubts? Okay, shall we go for next sensor?
Generation evaluation of your IoT devices. What is connecting devices? I told connecting your PCs, desktops, static machines were connected initially, and information was shared among the people. Next is your wave 2 is your mobile computing, cloud computing, and your wireless network. I was able to have my mobile phone in my hand, access the information from the cloud. Cloud is a storage space with the help of my Wi-Fi connectivity, wireless networks. That is the second wave generation. So the combination of mobile computing, cloud computing, and my wireless networks. Third wave, I was able to connect things, Internet of Things. I had physical devices, there were more number of physical devices connected together for performing some operations or performing some process. The next wave, yes, I have connected the devices. The device will tell water is available or not, water is filled or not. That identification, that interpretation of the data I have done with some sensors. After interpretation, what it should do? There will be human intervention, what to do. Human is thinking what to do next, and it is generated in the form of machine learning models and given. That is artificially we are inputting the intelligence through the machine learning models, training the machine learning models with the historical inputs. That is what is AIIoT, artificial intelligence of things. Next generation, we have connected intelligence among devices. We had made intelligent devices to interact. Where is this intelligence procured from? We are storing every data in the cloud. Operations process are carried out in the cloud with the help of service providers. We have many Amazon service providers, Apple, everything, all are providing services with the help of those services, but it is located somewhere far away. I am accessing only with the help of my internet. Only if my internet is fast, I am able to access the information. If the net is slow, my response will be slow. There will be a delay in the response. So that was the limitation. So overcoming that limitation, we move on into edge IoT. Edge. The place where it is generated, I will provide my operation also nearby the same place. I will have the operations performed in the edge of the network itself. where the data is generated. The earlier case, it was data will be generated in my physical device, there in my ground. But the data which I have to access will be in the cloud. The process what I should operate on the data collected will be done in my cloud. Later, if at all I have a proper internet connection, I will be able to get the response faster and perform the operations. There were some operational difficulty in that stage. In the case of your self-driving cars, suppose there is an object intervention, a human process, an animal process. The response should be faster. It should not wait for the operation to go to the cloud, fetch the status over there, match it with the data with the ML algorithm there and bring here. Before that, something will happen there, accidents may occur, it is a loss of life. So in such case of applications, healthcare applications which have a critical usage, because it all is based on the life of a human. In that cases, we can have chips in the same microcontroller. We will have the data storage in the chip. At the edge of the chip, at the edge network itself, in the same board itself, we can have another processor which will operate on these data which the sensors has connected. That we call it as a edge computing. That is connecting your intelligence. How industry has evolved with all these improvements in the technology. Now we have seen the technological evolution. How this technological evolution has been incorporated in our industry way. So industry 1.0 was your mechanical work. Your steam powered mechanization is what? Your energy will be converted into actions based on the steam created. That is normal motorization, normal mechanization. That was our base when our manufacturing industry started. Then industry 2.0, there was no IoT role in that. So industry 2.0, mass production with electricity. Then came the power into existence. We were able to generate power, use the power for the operation of the machines. What did they use in the basic machines? Basic sensors and basic control to manage the sensors, basic control systems. Industry 3.0, all digital revolution, all analog waves, analog signals created by my objects were converted into digital forms. So digital electronics input. Your programmable logic converters will give electronic operations, perform electronic operations. So there we had automation. Your supervisory computing and data acquisition system. From the remote place, you are able to access the data and perform operations on that. That type of automation, you call it as automated performances. Your supervisor machines means it is there somewhere in the remote location. It is able to access the data and provide control to the data which is operated. That was the invention of your industry 3.0. Next you have industry 4.0. Here comes your smart factories. Yes, I am able to operate from the remote. That I have done. How it should be operated? In a smart way, in an intelligent way. It should understand the machine better, evaluate the machine better, provide decisions better. It should be done by the machine itself. But how the machine will do? We as the humans, we have to train the models. How are we training the models? We write machine learning algorithms, make the history learned by the machine, understand the current situation, predict the future. That is how it is inputted to your smart factories. Your artificial intelligence was inserted. Cyber physical systems, many systems together connecting and providing automations. So it is fully IoT, yes. My devices are connected, my devices will be able to interpret the information. The sensor which is providing the signals will be interpreted by the machines. Yes, I am able to give AI integration. It is operated with the machine learning model, so it is made intelligent. Self-optimizing machines, this is what I said. The human is providing the input for the machine learning. It evaluates, the machine evaluates and provides decision making. What type of decision it makes? Optimized decision. What parameters it has to adjust for improving the performance, for improving the quality of my output. All this will be done by the adjusted by the algorithm, the machine learning algorithm you write, you train for your models. So the machine itself does based on the input in the first stage. It decides accordingly and optimizes the machine's performance.
Analyze what is the problem was happened, what is going to be happened. So proactive, reactive measurements I can able to predict about my manufacturing scenario, right? The fourth one is we are standing here talking about the psychophysical system. Psychophysical system is more popular because of it is easy to implement. According to statement given by the most of the engineers, so the psychophysical system is very easy to implement. Why easy to implement? In the sense of I am not disturbing any physical part of my infrastructure unit. You understand my point? There is no, I'm not disturbing my infrastructure part. I'm going to be disturbed in terms of the computational algorithm. So I'm going to be developing my computational algorithm. That algorithm will be help you to control the physical behavior of my model, isn't it? So I don't trust the complete model of my system. I just believe my computational algorithm to manage my all operational sector in the particular product development. And the fifth generation, I said that cyber physical quality system. This is a more popular. So direct. So there is a two automation process there in the industrial scenario. One is robot, another one is cobot. Can you be able to differentiate two things? I think you may know what is the difference between a robot and a cobot. Cobot is nothing but machine-to-machine interaction. Robot is nothing but human-to-machine interaction. The fifth the stage that we are developing this scenario in the most of the industry is cobot. The cobot is what the human won't interact with any kind of alien machines. The machine is going to be interact with another machine that the decision has been taken by himself. We won't interfere in any scenario. So this cobot is very popular in most of the scenario. The first, the Siemens company, they have been implemented the cobot in the abroad. So now it is under processing. If it is succeed, the human is not required to manufacturing all the products, even pencil also, is it? Now people will ask one question, sir, you are saying that psychophysical system is very important to all of the machinery industrial applications. Sir, what is the level of evaluation, sir? Where it has been started, where it is going to end, or it's where it is going to implement. So the first stage one, what they have done is the basic data availability. What is data availability? So I'm going to be observe the data with help of sensors. Of course, cyber physical system, the physical meaning is the physical component which are appear on the machine. What are the physical component will be there? Your sensor is playing major role. See, I'm asking a question in the beginning of lecture. What I have asked, what are the facilities, what are the future have been identified into car while you are driving. So a lot of facilities. It is completely related to the sensor. So I need a data. So the first evaluation of a cyber physical system to observe the data. So what are the data are actually there in our environment. Based on that, we are going to work, we are going to be analyzed, we are going to be processed, we are going to control the complete devices. So the data is a main parameter of cyber physical system. The stage one, you need to collect the data. After collection of the data, what I have to do? I need to analyze. Of course, what do you mean analyze? Which data is required, which data is not required, which data is not suitable for my manufacturing scenario, isn't it? So suppose I'm the company people that I'm going to be manufacturing on CRO. So if I want to manage my CRO, first I have to fix what is the size of the CRO, what is the screen size of the CRO, what type of frequency that I'm going to be using. Everything will be coming into the single part, isn't it? With the help of the psychophysical system, we can able to control without touching any hardware part. Because of I'm having the computational algorithm. With the help of the computational algorithm, I can able to evaluate the overall performance, the optimizing value, optimizing frequency, everything could be able to see now say environmental. Okay. So this is the second evaluation of psychophysical system. To state that I'm going to predict my optimized data. In the sense of in this stage they have developed one fault tolerance model. What fault tolerance model? According to the data observation from your manufacturing unit, I could be able to predict whether the data is a right or wrong data. If it is a wrong, of course, the next half an hour, there is some fault will be going to occur in the system. So this process is evaluation in the sense of stage 2. Stage 3 is very important that after analyzing what will happen, then we will predict that suppose the quality or quantity is going to be dominated by this wrong data. What is next I have to do? The third important is real-time data is very important. Why not? It's possible. See, while measuring the sensor data from the manufacturing unit, so you are observing that something is going to be happen. So the time itself you can able to moderate or you can able to adjust the parameter. Meanwhile, the product is going out. So this start was happened in the area of active data concept, right? The last stage, what will happen? Now I'm going to take the action. The last one, autonomy is to adjust the production parameters. schedule maintenance tasks and optimize the resources allocation based on the incoming data. Now, initially what I did, I just collect the data. Second, what I did, analyze the data. Third, what I did, activated the data. The fourth, what I did, very simple, action-oriented data. These when you for a level of the parameter when is integrated, we will call it a cycle physical system.
Is evolution to industry 5.0, and then there are a lot of key technologies involved in the industry 5.0. With the limited time, we will be focusing only key items which is present in that area, and then we will jump into human machine collaboration. Then of course each and every advancement in the system will have its own opportunities and challenges. We are going to see what are the challenges and case studies with the real world examples, and finally we can interact and conclude this session. So first, what is industry 1.0? Okay, so while coming to industry, I don't have to explain what is industry, but what is evolution of industry. So in before that 1800, like 18th century, before the 18th century, all the people were doing all the activities manually with small equipments which are helping to increase the productivity or to do the to make the process easier. But what happens in late 18th century is the mechanization. So people have created some mechanical items which will help the process to get mechanized. Importantly, that time they have created the steam power. So with that they have created the engines, right? Steam engines. So that era is called as industry 1.0, where it happened in the late 18th century, you know that, and the mechanization, steam engine, textile industry are the booming areas where it got revolutionized. So in that, what are the advantages? What are the advantages that happened during that time? Before that, everything was done manually, so definitely some errors may occur. But when we are doing it with some machines, definitely the quality will be increased. Not to the 100% expectation. Even if it is not 100% expectation, definitely the quality will increase, and speed will definitely get increased. You will definitely understand that. And most importantly, uniformity. If we are manufacturing some number of equipments, all the equipments will have uniformity. In case if you are doing it by manual, definitely there will be small changes will occur, but uniformity will be there. And considerably very good quality than when person doing by hand. So those are all the important advantages happened in the era of industry 1.0. And what is industry 2.0? So during that industry 2.0, electricity had given the major turnkey in that time. Electricity was invented during that time, 1870s time frame, and many things happened in the production industry. Say for example, earlier when person was using some machines, a same person has to do all the activities, like say for example of assembly of engine. So assembly of engine, a person has to do from the initial activity till the assembly of that. So same person will do all the activities. But during the industry 2.0, they have introduced a new concept called assembly lines. You know that already. But during that time only, assembly line was introduced. So assembly line is a line where the product will be moving from constant speed or some various speed in a line, and multiple members will be doing some particular activity on that to build that. Say for example, one person will put bolt, one person will put the piston, like that. So different person will do different activities, but a single person will do some particular activity only. So the speed of the manufacturing will get increased. In addition to that, the perfection will get increased, and there are a lot of products can be manufactured parallelly.
Pressure water is used to cut any material. Okay, you 1 inch thickness also you can cut. Simple water cannot cut. It has to be set at high pressure. Okay, even with high pressure you can cut cake or thin sheets like that. If you want to cut heavy thing, you have to add abrasives. There is an abrasives like a sand. We will add it along with the water jet. You can see here. This is the point rust. Okay, there is a nozzle. You can see some abrasives are added. Along with the water jet. Okay, so both are mixed together. When it mixes together, when it comes out, it comes with high velocity. Okay, 900 meters per second. When it comes out, it cuts the material. Okay, this is a machining process in manufacturing. Okay, I want to cut some material, you can use this. Okay, very thick, I want to cut it, you can use this material. Okay, right. By drilling, you can make a hole. Milling, there is a technology, you can machine with conventional tool. Very high strength material, which is used in rocket or space technology. You cannot cut with the traditional machining, so you have to go to non-traditional machining. Are you clear now? So what will happen if water and abrasives go into the nozzles? If the nozzle will wear, internally nozzle will wear. Is it right? How long we can use? That question comes. Normally, the nozzle is used for 50 hours. But the operator will not know when to change the nozzle. What is the condition of the nozzle? If in good condition, you can get more depth, good finish on the surface. If after usage for 10 hours, 20 hours, the finish will not be good. Okay, then when to stop? Operator may not know. Okay, so now this is the problem. You find in the industry, operator is struggling when to change the nozzle. So one issue we have identified. Technically, okay, right. Now what we have done? Okay, this is a typical nozzle. You can see this is a secondary nozzle through which the water comes out. Okay, you can see this abrasive sand. When the sand is mixed with high pressure water, it will cut the material. Okay, the sand is having various shades and shapes. You can see the finish of the cut. Okay, this is how it cross-sectional view of the cut. When you move very slowly, the nozzle good finish will get. When you move the nozzle very high speed, it won't cut smooth finish. Okay, there are some advantages and disadvantages. You can see the jet comes out and how it cuts the material. Okay, right. You can cut any material. Now you can have a better understanding about this machine. The water jet high pressure. Mechanic people knows. High pressure water is used to cut the material. Within 15 minutes you cut. Okay, if you cut by half saw blade, traditionally in your workshop, first year students will be doing, no, it will take 2 or 3 days. So that is the difference between, okay, so this machine I used in master degree when I done my research in IIT Madras. After joining America, I purchased these machines through UGC SAP project, some 60 lakhs, something like that, okay, right. So this is a typical machine we have installed, okay. Now the problem is about this nozzle, when to change the nozzle. Now people are talking about industry 5.0, they are talking about IoT, they are talking about sensors.
Or any of the type of innovative idea of product, you want to make it means you can be able to print it and it will be like physical model only. So not you can't go for real time application purpose. Now here I am having in this hand this is the product which is they will be lacking like one side is fixed and another side will be moving on. So it may
ஸோ இது வந்து மெயினாக எதுக்காக பண்ணியிருக்கோம்னா ஸோ இப்போ வந்து ஒரு என்டையர் எம்ப்ளாயிஸ் ஸோ அந்த மாதிரி நியூ எம்ப்ளாயிஸ் வந்து ஒரு இண்டஸ்ட்ரியில் வரப்போ ஸோ அவங்களுக்கு வந்து எப்படி அசம்பிள் பண்ணணும்னு தெரியாது. ஸோ அதுக்கு என்ன பண்ணுவாங்க, ஒரு ட்ரைனிஸை வந்து அலோகேட் பண்ணி ட்ரைன் பண்ணுவாங்க. ஸோ இப்போ நீங்கள் விர்ச்சுவல் ரியாலிட்டி மூலியமாக என்ன பண்ணலாம்னா, ஒரு கேம் சிமுலேஷன்ஸ் வேல நீங்கள் என்ன பண்ணலாம்னா, ஒரு கியர் பாக்ஸ் வந்து அசம்பிள் பண்ணலாம். லைக் அவங்களே இன்ஸ்ட்ரக்ஷன்ஸ் வந்து ப்ரொவைட் பண்ணிடுவாங்க, இன்ஸ்ட்ரக்ஷன்ஸ் ப்ரொவைட் பண்ணிடுவாங்க. ஸோ ஸ்டெப் பை ஸ்டெப் ப்ராசஸ் வந்து நீங்கள் ஃபாலோ பண்ணி ஒரு கியர் பாக்ஸ் ஃபுல் செட்டப் வந்து நம்ம பண்ணலாம். அப்புறம் வந்து விர்ச்சுவல் ரியாலிட்டி. So we have a demo in a human anatomy. So you can try to practice.
Also on research consultant for many other industries in curriculum development and syllabus development. You will have a teaching department. They enrich the institution by using the education department. Of course, in India it is not there, and of course we don't give much importance to that education department. Okay, and actually you have NIDDR, you have that education department. They are the people. They will be developing the curriculum. They will understand a lot of problems with the teaching and students and how to promote it for the product-based development. They do the research. They develop the curriculum. Of course, what we do is that we take from primary university syllabus and we do it. They don't do like that. They are reputed industries. Their curriculums are being developed based on their customers, based upon their requirement, and based upon their students' ability to develop. Of course, this to be discussed only in the NAC and NBA. That is not a part. But still, what I am trying to say is that my experiences with the other universities, because I developed research nexus syllabus, how to promote research and product-based development. Apart on that part, and this session is going to be here. Now, you all talk about Industry 5.0. What do you mean by Industry 5.0? Why it is 5.0? See, the thing is that how humans and how machine both is going to work equally for developing a product. Okay, 100% we cannot give anything to the product. 100% we cannot give it to the human. See how both are going to collaborate. That is a very important thing. Of course, if you have much interested, we think that Chennai people are doing better in engineering, but actually, what is my opinion is that we are totally lagging. Though we are in heart of the city, but I feel that Coimbatore has become the best zone. And a lot of people from Coimbatore side, rural side, they are developing a lot of products. Of course, it is not coming up. You can just take one product. It is called Mobitech. Okay, I'll just show you so that you can even take your students to that understanding the real-time product development based on AI, based on deep learning, and based on what I can say quantum computing and quantum machine learning. Because you talk about deep learning, but now people are working on quantum computing and quantum machine learning, and they are talking about quantum processors and quantum sensors. The entire which is totally different, which is going to change the entire processing of the electronics and computers. And that is what the reason many quantum labs are being developed. People are focusing on quantum computing. Okay, I think you would have heard about quantum computing. Okay, the future is only quantum machine learning. Okay, that is a different part. But when you talk about industry, why we call it as 5.0, interaction between human and industry, and that is the main important thing. Okay, we will not let the machines to work independently. At the same time, we will have the control. That is a very important thing. Okay. Now, when you talk about introduction, I think your senior, your topic is a very intelligent topic. I don't know who has coined this particular topic, but no, it's a very beautiful topic. When you see literally, I think people may not understand, but when you see in depth, it is having a lot of beautiful informations, but the only thing is that, I don't know, so far from people who given the information, whether they were able to club IoT, robotics, and then AI, and then and you are all multidisciplinary area to be clubbed. Ever you have been learned how to club all those things? How to club AI and robotics? And that is your topics. You're supposed to believe, correct? Multidisciplinary application of AI, IoT, robotics, integration. How do you integrate it? Anything? Robots. What do you mean by robots? No, I'm just asking you, how you interface it. How do you interface your topic? You say multidisciplinary robotics, and you say IoT, and you say how to do that.
How to do that means what?
How to interface it?
Interface means using software, sir.
No, that is what I'm asking. You have to tell me. You have taken the course for what?
No, you are asking the question. What you are expecting is?
What is it expecting is that how to use all these things in a single product.
Example, unmanned vehicles.
Unmanned vehicle. Okay. Unmanned vehicle. What it happens? Unmanned vehicle will have only wireless, not IoT. It is not connected to.
Information computerized.
No, you cannot connect it to IoT, no.
Sir, edge computing, about that they talk, so it is connected with IoT only.
No, I'm talking about the product.
Right now, unmanned
Unmanned
vehicle is considered.
UAV is that you have wireless sensors. You collect your data, but it is not connected to the cloud IoT. That is what I'm asking.
Sir, autonomous vehicles, sir,
Huh?
it's related with computing, autonomous vehicles, edge computing.
CCTV camera is to be collecting their vehicles,
Okay.
classification of all the things,
Data
and
itself.
send it to the cloud, and cloud will be seeing all the things.
Impact is called as first revolution. Now what is second revolution? Electricity. So what happened when we got electricity? Even 5.0 is happening because of electricity, right? Even somebody says tomorrow 6.0 or 7.0 or 10.0, it is only because of this, right? So electricity is inevitable. So the second revolution we started with this thing, electricity, and we began to set up assembly lines. So what you have seen in mechanical assembly lines in industry, right? So there will be conveyor belt going on here and there, and most of the automation happens through those conveyor belts and because of electricity, right? So we are able to produce more, right? But in India, I think rather than India, other Western countries were able to give more. They have given more importance, and more production lines are set up in those countries. So it began in Europe and America. And electricity, petroleum, steel, mass production assembly lines, and then we got more job opportunities. Correct? So electricity, job opportunities were more, and we have energy sector, we have other core industries are emerged. Then comes industry 3.0. What happened in industry 3.0? Electronics. Electronics with electronics and IT. So basically, it has also started automated production, right? So a little bit of automation means that we were able to introduce sensors. That moment, we were able to introduce sensors, but sensor integration was not happened at that time. We were able to introduce sensors. We were able to do something automatic. So, for example, earlier we had placed an object on the conveyor belt and the belt was moving, and then we were slowly dispatching manually. Then we got some sensor, so it got automatically it gets stopped at the place where it wants to stop, right? So the idea of sensor, not sensor integration basically, idea of sensor has begun in this revolution when electronics and IT or automated production happened. So in fourth revolution, what happened? Yeah. So what is the difference happened when IoT came into industry? Yes. In third revolution itself, we started to use sensors, but what impact IoT has given us? Yeah, we were able to integrate many things. So, for example, if you take car has majorly got benefited because of 4.0. If you look at cars, let's say there is an engine, right? When there is a crash happen, automatically airbag opens up. How it is being done? Because they are integrated with each other. A crash on the car or a crash sensor is integrated with airbag. Let's say the wheel speed, or if suppose any trouble comes because of air pressure or any damages, it goes to engine, right? An engine pops up or engine get stopped or engine will not start, pick up starting. So that means in industry 4.0 we started to integrate.
Right, okay. Let us start with a simple definition. What is machine learning first? Like, so before taking any session, we should have a differentiation between what is machine learning, what is AI, what is deep learning. Then we will see what is a machine learning is all about. Okay. So what is a machine learning first of all? Like there are certain learnings, I can say that. So we are learning, that we have a learning mechanism, we have a schools, we have a colleges, we are learning, the teachers are teaching. But there are certain things we are doing automatically. It's called intelligence, I can say. Some intelligence, let's say I'm just giving a pictures of 10 images. So wherein I'm just stating this is a parrot, this is a peacock, this is a dog. I'm just saying that. So how do you describe that? Whether we are describing it? Not at all. We are not describing this a color and all. Right? So by seeing that, someone is teaching this is a parrot. Okay, that is the intelligence we are taking. There is no mathematics, there is no formula, nothing in it, but we are learning there. So that is the one type of intuitive learning, or we can say it's called intelligent learning. Now, people come up with the computer science program, which can imitate such kind of program, is called the machine learning program. Okay, so simply I can say another way, machine learning is all about learning something from the data. You can simply say, very simple, longest definition, I'm just bringing a simple definition. Learning from the data. Okay. So what was the learning from the data? I've given one example. What was the example? A picture is a data. Through the picture, you are identifying something called a dog. So this is learning. If you are writing a computer program for that, then we can say it's called a machine learning program. Then second thing, what I mean by data, is it only the image? Not at all. Let's say there is an audio. From the audio, if you could identify someone, this is a A.R. Rahman or is it a Malaysia Vasudevan? So that kind of intelligence you are doing, if you are writing a program for that, then that is called machine learning. So data means text from learning. Whose handwriting is this? Is it a woman handwriting or a man handwriting? So a lot of things we are learning actually. So data means everywhere there is a data, text data, video data, audio data, all we can say data. From the data, if you could recover something, a hidden information through a computer science program, you can say it's called a machine learning. Right, okay. Then what is this AI? Is it both are same or different? That's the question. And you can interact because afternoon session, so please interact, that will be better. Right? What is an AI? What is an AI? Machine learning, it's fine. Learning for the information, or we can say another way, we are finding the hidden patterns in it. There is a hidden pattern, our brain is recognizing but some information, right, okay. So what is AI? What is AI? What is AI? Is it both are different or same? AI? Definition wise, what AI definition says? Whatever the human being doing, if you imitate that, or if you mimic anything related to the human, actually we can say AI. Right, then how this is machine learning and AI is different? That's the first question. How these two things are different? We have 6 senses, right? So consider the last, you just ignore the last sense. Last sense is called the 6th sense, right? So 6, if you forget about that, take the 5 senses. What they are? What it is exactly doing? See, like sensing, it's a vision data. Listening, it's audio data, right? So all. Yeah. So what I want to say is like it is a kind of approximation or a learning algorithm from each sensor. We can say all our sensors. All sensors are working like a machine learning model, right? Maybe 1 or 2 machines. So every sensor is a kind of machine learning model. By seeing the person, one machine learning model is called. Okay. By seeing, I have a collection of machine learning models which is there in my mind. so many machine learning models. Like seeing the text. Okay, I have a lot of machine learning models. But what is the sixth sense? What is the sixth sense? Five senses, I'm understanding something. This is what, this is what, this is what. Okay, this is a red color, it's a black in color, this is a blue in color. All I identify through machine learning methods. What is the sixth sense basically? By considering all, I should take the maximum decision. Let's say, I think the olden days kannal pakkadum poi kaadal kettum poi theera visaadipade me. That is the AI. AI which gets all the information and try to correlate that, which comes with the maximization function of that, which decision is the ideal decision for that is called AI. So AI needs a knowledge base, AI needs sensors, AI needs agents. Agents are machine learning. Okay, one real-time example I use is
So the vehicle is moved backward. So the vehicle is moved and then the vibration is detected, then automatically it sending an alert to the SMS. So for example, if the alert is received means, so automatically you can see the message. So accident, if any accident is occurred, how the accident will be occurred with the corresponding location. So if I press this location, then automatically it turn to Google, then it will be sent whether which location it can be accident. Then you can click directions. So from where to where you need to go. If any vehicle get accident, automatically it send alert to the users. So for example, any relative or so then directly will reach the designation.
Here we included as an any type of vehicle for this automation. Airbag devices. Actually, in real motor RPM is 60 RPM, but we reduce it to 30 RPM because of speed. So if I press it, it goes to a high speed. That's for demonstration we did using a spur gear mechanism. Half of the speed.
So it is prototype in terms of model.
Depend upon the speed, we can vary.
What is the cloud platform, sir? That
actually we have one from so through this we have control only for demonstration. Actually in real time it can be enclosed with a smart product, but it's not open and visible. So this will be created by an open type. Skeleton. So smart sensors, wire harness, everything will be tied. Connected to the DC motors. Yeah, DC motors and AC this is also actually this will be a high-end switching operation. Motor can operate in but other motors are operating.
Is an 1950s, they thought, okay, it is not available, so we name it meta. Meta means beyond the availability, so they term simply as a metamaterial. Okay. Now, what happens in simple physics? Look at this. When it comes to refractive index, okay, when it comes to refractive index, it is a combination, basic equation. It is a combination of mu and epsilon, right? Now, what will happen when you have the both positive? You are happy to have positive value of refractive index for the most of the materials. But what will happen when both becomes negative? The one explanation would be that negative becomes positive, and the material will behave as if there is nothing has changed. So there is nothing surprise will be. The all physics what we have developed will be equally valid. The second idea is, if we have two negatives are there, we can take minus is minus 1 is minus 1 squared, and we can keep simply it outside, and in that way the refractive index becomes negative. So what will happen if we have the negative refractive index? The first thing we observe that when metamaterial come into the picture, the refractive index becomes negative. Now what will happen if it is negative? Very simple. So that's Snell's law. Simple simulation. Look at this. The wave is coming. Okay, it's a phasor diagram. So wave is coming, interacting with the interface here. Okay. Now look at
related courses. Very well. Right. So that's why the AICTE is already designed to make them to allow other branches, other department faculties to study this particular course of 6 months, 3 months, then they are allowing to take classes for computer science related courses. It's happening. In fact, in our college itself, there are 3 faculties have been already done and taking 2 classes in computer science. I hope this will change the whole scenario in the teaching industry. As far as the industry is concerned, and I really appreciate all the speakers, the so-called resource persons for the past 6 days, starting with Dr. J. Kamala, then followed by Dr. Ram Prabhu, and Dr. Sabiyat Fatima, and then Dr. Wasim Babu, and then Sasikumar Jayasundran, and Sangar, and Dr. Karthik Raja, and Mrs. Srija, and Siraj, and Rajesh Khanna, and of course finally Dr. Rajesh. I expect this is going to be a wonderful day for everyone, and you will get your certificate very soon, and we will try to apply further FDPs. We try to conduct many more events like this. I wish you all the best. Thank you very much.
Respected Principal Sir, respected Vice Principal Sir, my dear friend Abbas, and my dear fellows. I hope you have enjoyed this, and the best part I thought is the name of the FDP itself. It says the multidisciplinary, right? So I tried to justify the topic by applying the optimization technique on various topics. I understand that within a short span of time, it is very hard to grasp everything. But even if you get motivated, and even if you get some basics, that is more than enough. Once you have a track, you can travel a long distance. So getting track is the most important thing. And these FDPs are basically meant to provide such tracks. And I really want to congratulate everyone, for myself also, you also, and to the whole team who has actually worked very hard. And being the coordinator of this FDP in the last previous year, 2023, I can tell you a lot of pain has to be taken by the coordinator, Mr. Abbas, and whoever is vice president also, because a lot of background work he has to do to accomplish the documentation side. Because the government has track of everything, required everything, how many lectures have been done, who have done, what are the performance, what were they taken away. He has to make a full report of that. So, and then he will go through it, right? So, and that much of, to take that much of pain, obviously he has got permission from this administration. So, equally the administration is, we must give a big round of applause for providing such a moreover, also, it was a very nice experience for me to come from such a long distance once again, the second time in my life, and have interacted with you guys. And I wish whenever I have such FDPs there, I will really pass my catalogs to my friends, now to all of you, and I wish you should all come there. With these words, I wrap up. Thank you.
Thank you, sir.
So thank you all for providing such versatile as well as resource person and hands-on training and hospitality. So thank you all.
One and all present here. On behalf of St. Joseph's Group of Institutions, I would like to thank our coordinator sir, Dr. Mohammed Abbas sir, and co-coordinator Professor B. Mahesh sir, for arranging this wonderful FDP, sponsored FDP on multidisciplinary applications of AI, IoT and robotic integration with Industry 5.0. So I belong to EC department. So from this instant onwards, I think I have to look in for project where all the discipline will get involved into the project. That's what I got my takeaway from this FDP. And apart from that, the session speakers and sessions was very good and informative. And visit to TANSAM yesterday was a great experience for me. And finally, the time management and information sharing through WhatsApp and the planning was so good. And thank you all for giving me this opportunity. Thank you.
Good afternoon, everyone. I am Dr. R. Srinath. I am working as an assistant professor in the Department of ECP. I would like to give some candid feedback about this 6 days ATAL sponsored FDP. Hope no one will mistake me. Positives about this workshop are two. One is the topic which is chosen is really needed, and the speakers which are completely in line with the topic, that we all have to agree. The insights what they have shared is highly informative. That is the one positive thing. And second thing is the coordination among the faculty was really awesome. I have attended so many offline workshops where only couple of coordinators will be moving around. Here a lot of HODs are sitting here, and from the day one, not because of the attendance, from the day one onwards, they have been seeing this workshop and they have been getting useful insights from each and every sessions. So those are the positives I have seen, and a lot of information we got it wholeheartedly. I am saying thank you so much for Abbas sir for organizing this. From the day one onwards, he was keep on tracking us. I mean, sharing the PERI Institute location and a lot of information were keep on posted in the WhatsApp from day 1 to day 6. He was keep on doing all these things, and my special thanks to Mahesh sir as well. And certain drawbacks, like not as a drawback, you can just take it as a scope for improvement. Like during refreshment times, the refreshment provided was really very good, but the lunch was not up to the mark. So sorry sir. So please look at it. That is the one point. The second thing is the research gap. We want more research gap, because nowadays every college is expecting some publication from faculty side, right? So that research gap from the experts is what missing, and hands-on session. Hands-on session is all because of us, right? Hands-on session you can just, when you conduct next TIDEL FDP onwards, you can just shift the hands-on session in the morning, so that we can work on. You can just give us some basic model building, because I'm into AI. I work with a lot of AI models. So you can just, at least you can just give an awareness to how to train a neural network model, so that you can give this information to us. So you can just shift this hands-on training instead of keeping in the afternoon session. You can just postpone in the morning. So apart from that, this was wonderful experience with you people, and thank you so much for a lot of supporting PERI Institute faculty members.
Thank you, thanks.
First, I would like to express my thanks to PERI Institute of Technology for organizing this wonderful FDP. Really, it was very informative, and all the sessions are very informative. And it is not because that Prakash and then sir was sitting, it's from the bottom of heart. Your session was highly informative and was really amazed to see your expertise in various domains. Even in the feedback form, I chose your name as the best resource faculty. This is the one I thought in my mind. And all the sessions were planned systematically, and whatever the queries we posted, they answered regarding everything. They answered quickly, and special thanks to Dr. Abbas sir for organizing this. And literally, he did everything in a systematic and organized manner, in a cool way. That's the lesson what we are supposed to learn. If something happens, we used to be very tensed and show the faces. I never saw that sort of face during these things. Thank you, sir.
So, not only for this FDP, I joined this institution last September 2nd. So, past 9 months, I done many activities towards this college development and also for other process. But for all the things, the entire activities, they are given full support. I really thanks to again management and also principal and vice principal sir. So this FDP concern. So I think many people are given some thanks to me, because when madam said there is no tension in my face, because I am the man in front of you, but behind me I think the vice principal will be there. So who is the man taking all the tension, all the stress? So just I am in your face. So whenever I am struggling, wherever I am struggling, then I will inform to him, then he will solve the issue, then he will take in the tension, then I may be free. So that's why I always smiling face along, you people with you, among with you. Thank you, very good. Thanks for your first information, ma'am. And also, I express my sincere thanks to organizer who was with me for the past 1 week, I think so, like a marriage day. So every day, normally marriage day will be the one day, but the entire day, all the 6 days will be the new day for us. So all the organizer, like particularly for the QC team, because they are completely with us, and also for some people from the mechanical and ECE, definitely I never forget about their work, because many works behind that all the works are carried by very smooth manner. And also I express my sincere thanks to the head of the department ECE, Dr. Rajeshwari ma'am, head of the department EEE, Rajeshwari ma'am, and also HOD mechanical, because they are completely along with this FDP. Already sir said, I think in all the session, who are the person always inside here, then whatever the requirement from the participant, I think they have fulfilled somewhat, almost all the aspects. And also, I thank all the already sir clearly informed all the eminent speakers, so I need not mention their name. I think without them, the FDP will not be fulfilled completely. So I express my sincere thanks to all the expert speakers. So almost we chosen all the speakers are very eminent people. I think you are received the knowledge from them, received many information from them. I hope this FDP is completely helpful for you. And also I express my thanks to again for all the faculty members from PERI Institute of Technology, all the heads of the department, non-teaching, and also for the technicians who were involved in this FDP. Also I would like to thanks to all the participants from various engineering colleges, because without you, this FDP will not be fulfilled. Once again, I thank you everyone. I thank you all. Thank you very much.